Welcome to the debate. Usually when we talk about a failure rate of 95% in any major corporate initiative, we are talking about an absolute scandal.
Oh, completely. It would be a disaster.
Right. I mean, if a city commissioned 100 bridges and 95 of them collapsed into the river before a single car ever drove across, you would stop building bridges entirely.
Yeah, you'd demand a federal investigation.
Exactly. But right now, we are looking at this stark reality of enterprise AI, which was perfectly captured in the 2025 MIT Project Nanda research. While roughly 60% of organizations are aggressively evaluating enterprise AI, a staggering 95% of these initiatives fail to reach production with any measurable financial impact.
Which is just a massive number.
It is. That means there is a massive 75% drop-off just between a successful pilot phase and actual deployment.
It is an incredible attrition rate. And honestly, the natural instinct for most executives when they see a chart like that is to blame the algorithm.
Right.
We just assume the AI simply isn't intelligent enough yet to handle the sheer complexity of a multinational enterprise. Or, we think the large language models are hallucinating too much to be trusted with real financial data.
Precisely. We blame the bridge materials. But this massive drop-off is not a failure of AI model intelligence at all. I mean, the models are incredibly smart. It is fundamentally a failure of enterprise architecture.
Okay.
So the central question we are debating today is exactly how we solve this structural flaw. Like, should enterprises rely on external centralized data lakes, what we call the overlay model, to maximize AI accessibility across the company? Or must they adopt zero-copy architectures that embed AI directly into existing operational systems to preserve the original business context?
It's the core dilemma right now.
Yeah. And when I look at the 75% drop-off, it tells me we must completely abandon these disconnected, isolated brain models. We have to activate intelligence directly within our existing operational nervous systems to, preserve that critical business context.
And my view is that, while preserving that operational context absolutely matters, the centralized overlay model provides essential ease of access, whereas distributing AI into deeply embedded systems and relying entirely on vendor-maintained networks introduces severe fragmentation and governance risks.
Well, let's actually unpack the mechanics of this, because we have to understand exactly what happens to data when we move it, which gets to the heart of why these AI projects are stalling in the pilot phase.
Sure.
For years, enterprises have treated AI as a third-party overlay. You build a massive central repository like a data lake, and you extract information from multiple different business systems and dump it into that lake.
Right, creating a unified view.
A supposed unified view. But that third-party overlay is, it's fundamentally an illusion. Because when you extract data from a complex system like an ERP platform, let's say SAP S/4HANA, you don't just move numbers. The data instantly loses its semantic integrity.
Wait, let's define that for a second, because semantic integrity is one of those terms that gets thrown around in architecture meetings a lot.
Fair enough. Think about a table in an enterprise database. You might have a column labeled status code 4. Inside the native SAP environment, the system knows that 4 means a shipment was delayed due to customs.
Right.
Which then triggers a specific 10% discount rule for that particular vendor, which is tied to a specific currency exchange rate from last Tuesday. That is the semantic integrity, the business hierarchies, the transactional dependencies, the time-dependent business logic.
The context.
Exactly. But the moment you extract that data and dump it into a central data lake, you strip away the surrounding application logic. The AI just sees the number 4. It's exactly like taking a complex, highly nuanced legal contract and translating it into a new language, word by word, without understanding any of the grammar or the syntax. The raw words are technically there on the page, but the actual meaning, the conditional clauses, the legal weight, they are entirely lost. Attempting to rebuild that time-dependent context in an external data lake is not just extraordinarily expensive, it is practically impossible to maintain.
Look, I come at it from a different way, because we cannot ignore the historical context of why we built data lakes and centralized repositories in the first place.
You can't just wave away the access problem.
Well,
Yes, the 95% failure rate is a harsh reality, but the fundamental logic of the third-party overlay model remains valid. Your legal contract analogy is conceptually great, but let's play that out. Sure, you might lose some nuance or syntax when you translate that contract into a central, standardized language, but if you don't translate it into a central language, your global legal team can't read it at all. We built these central repositories precisely to break down enterprise silos.
But at what cost to the accuracy of the data?
At the cost of actually being able to cross-reference it. Look, if your sales data lives in Salesforce, your supply chain data is sitting in Oracle, and your financial data is locked inside SAP, you cannot run predictive analytics across the enterprise unless you centralize it. And the MIT NANDA findings explicitly acknowledge that moving data makes AI easier to access. And access combined with experimentation are the absolute necessary precursors to finding any measurable financial impact. My immediate skepticism regarding your zero-copy alternative is about visibility.
okay, let's hear it.
If intelligence is strictly localized to where the data already lives, aren't we just creating highly intelligent but completely isolated operational silos? We are retreating from the unified enterprise view back into fractured department-level intelligence?
I hear that fear, though I would frame it differently, because I think the definition of access has evolved. The pursuit of a unified enterprise view through centralization, this constant copying and pasting of data into lakes, is exactly what has led to the 75% pilot to production chasm.
How so?
You noted that moving data makes it easier to access, but the reality is that moving data makes it much, much harder to trust.
Because of the lost semantic meaning.
Exactly. This is where zero-copy architectures and data fabric models completely change the paradigm. In a zero-copy architecture, we aren't creating isolated silos. What we are doing is leaving the data entirely in its native environment. It doesn't move.
Right, it stays put.
Yeah. Instead of bringing the data to the AI model, we bring the AI model to the data. The AI queries the information directly where it sits, reading it through the native application's lens. It understands what status code 4 means because it's asking the system that created the code. You preserve the semantic integrity, which means you maintain the trust. But through a data fabric, the AI can still query across Salesforce, Oracle, and SAP simultaneously.
That sounds elegant in theory, but let's look at the operational reality of maintaining that trust in an embedded zero-copy model. If the AI is operating inside these deeply embedded systems, understanding the native language of that specific software, who maintains that understanding? Because the industry reality right now is that in these successful zero-copy implementations, the model retraining and the semantic mapping are maintained by the platform providers themselves, the vendors, rather than the enterprise IT teams.
That's correct. The vendor providing the system updates the map.
This is where I see a massive red flag. Isn't surrendering the maintenance of your core semantic mapping to external vendors an incredibly dangerous loss of internal IT control? You are essentially outsourcing the understanding of your own business logic to a third-party platform provider.
I wouldn't call it dangerous.
Think about how bespoke multinational supply chains are. If the vendor pushes an update to their semantic model to make it more generalized for their broader client base, and it suddenly misinterprets your specific corporate taxonomy, your internal IT team is completely powerless to fix it because they don't own the underlying mapping anymore.
I see why you think that, and giving up control is always terrifying for IT, but let's be honest about what enterprise IT should actually be controlling in the modern era. For the last 20 years, enterprise IT has spent the vast majority of its time and budget doing exactly what you're describing, manually rebuilding time-dependent business logic, maintaining fragile ETL pipelines, that's extract, transform, and load, the plumbing that moves data, and constantly patching broken semantic maps. It is low-value plumbing. It doesn't differentiate the business.
It ensures the business is running accurately. I wouldn't call that low value.
It is low value when a vendor can do it natively and perfectly because it's their software. By shifting the maintenance of the semantic mapping to the platform providers who actually build the systems, IT is finally free to focus on outcome orientation.
Outcomes.
Yes.
The ultimate metric of success in enterprise AI isn't whether your IT team successfully mapped the database schema. It is whether the AI delivered measurable financial outcomes. We're talking about tangible metrics like reduced days sales outstanding or improved working capital. Enterprise IT needs to manage the outcomes, the user experience, and the overarching governance rules, not the underlying code of the semantic map.
Managing outcomes sounds fantastic in a boardroom presentation, but outcomes are generated by processes. If you don't control the semantic map, you don't fully control the process. And when we talk about governance, which absolutely must exist within the environment where the AI operates, you are placing a tremendous amount of faith in the platform provider's security models and compliance rules.
Which brings us perfectly to the operational reality of how these financial outcomes are actually achieved. Because if we are seriously focused on reducing day sales outstanding, we aren't just talking about generating a nice chart. We are fundamentally talking about shifting from an AI that merely thinks to an AI that acts.
Ah, the shift from generation to execution.
Exactly. The first generation of enterprise AI, the generation currently struggling to get past the pilot phase, focused almost entirely on generating insights. Copy pilots are a great example. They give you summaries, they draft emails, they recommend next steps, but a human being still has to read it, verify it, and click a button to execute the final action.
Right.
What the industry is moving toward now is the chain of action era. We are moving beyond copy pilots to autonomous agents that operate directly inside operational workflows. Instead of an AI simply flagging a tax anomaly and putting it in a colorful dashboard for a human auditor to review on Friday, a chain of action agent initiates the corrective workflow directly. In real time, we're looking at agents that autonomously trigger invoice corrections, make dynamic ledger adjustments, and execute compliance validations.
Wait, hold on. You just said the phrase autonomously trigger ledger adjustments.
Yes, I did.
I'm sorry, but I just don't buy that. Let me tell you why. The ledger is the immutable financial truth of an enterprise. It is sacred. We agree that automation must strengthen accountability, not reduce it, but giving autonomous vendor-maintained agents the power to make ledger adjustments across enterprise systems actively removes the human safety net.
No,
Think about the risk profile here. If a first-generation AI generates a flawed summary of a client account, a human account manager reads it, realizes it's wrong, and catches it before any damage is done. But if an AI autonomously adjusts a ledger based on a slight misinterpretation of a new cross-border tax code, you have just introduced automated financial contamination at massive scale. The speed of AI essentially becomes the speed of error. How can any responsible CFO possibly sign off on an architecture where algorithms are actively changing the books without human intervention?
I am not convinced by that line of reasoning because you are applying the governance limitations of human systems to cryptographic systems. It's a completely different paradigm of trust. Modern agent architectures solve this exact fear, the fear of a rogue algorithm wrecking the books, through cryptography.
Explain how cryptography solves a bad tax decision.
It solves the accountability of the decision. To maintain trust in these automated actions, the architecture relies on cryptographically verifiable identities and immutable audit trails. Let me break that down. Every single action performed by an agent, every invoice correction, every ledger adjustment is tied to a unique cryptographic identity using a secure hash.
Okay.
It is mathematically stamped onto an immutable ledger. It becomes perfectly traceable, verifiable, and explainable. Think about the human safety net you just praised. When a human makes a ledger adjustment, they might leave a brief note in a text field or they might not. They might remember their exact rationale 6 months later during an audit, or they might have left the company.
True. Human documentation is notoriously spotty.
Right. But when a chain of action agent executes a workflow, it leaves a mathematically provable, completely unalterable trail of exactly what data it looked at, the exact version of the semantic model it was using, what specific business rules it applied, and precisely why it took the action. For CFOs and regulators, this level of transparency isn't just new, it is unprecedented. It doesn't remove the safety net, it replaces a porous, fallible human safety net with a cryptographic, mathematical one.
That is a compelling argument for accountability after the fact, but have you considered the sheer complexity of managing these cryptographic identities when you don't just have one system, but a whole ecosystem of them?
Sure.
We aren't just governing one central AI brain making these ledger adjustments. If we move away from the centralized overlay model, we are entering what is widely being called the Internet of Agents.
Yes, and it is a totally necessary architectural transformation. The massive monolithic AI system, the single giant brain, is simply too slow, too expensive, and too generalized to handle the specific intricacies of enterprise finance and operations. In the Internet of Agents model, you have specialized, highly focused AI agents collaborating across distributed systems.
Meaning they are all talking to each other constantly.
Exactly. Imagine a complex transaction hits the system. Instantly, a specialized VAT agent trained entirely on European tax law flags a discrepancy. In a matter of milliseconds, it talks directly to a cross-border transaction agent to verify the currency exchange rate at that exact moment.
Wow.
That agent pings a financial risk detection agent, and together, using standardized protocols, they agree on the correct ledger adjustment and execute it. All of this happens in maybe 300 milliseconds without a human lifting a finger. It allows for a level of performance, accuracy, and cost efficiency that a single massive monolithic system trying to compute all of that at once could never achieve.
But just listen to the scenario you are describing right now. You have a VAT agent, a cross-border agent, a risk agent, all firing off continuously, communicating across distributed environments, executing autonomous actions, and logging complex cryptographic audit trails in milliseconds.
Yeah.
This sounds like a chaotic, highly fragmented ecosystem. The fragility of a system where a half-dozen specialized agents must all communicate flawlessly without creating infinite feedback loops or conflicting actions is immense. A monolithic system, for all its computational faults, its massive costs, and its integration challenges, is at least a single throat to choke.
But
It is governed by a single set of overarching parameters. A sprawling Internet of Agents introduces a massive new layer of architectural complexity. How do you practically govern a network of decentralized algorithms that are constantly negotiating with each other?
You govern them by using that very speed and decentralization to change the paradigm of compliance entirely. This distributed model, this Internet of Agents, enables something that regulators, CFOs, and auditors have wanted for decades: the end of periodic compliance.
You mean moving away from the yearly audit?
Exactly. Think about how enterprise compliance has historically worked. Transactions occur constantly, millions of times a month, throughout the year, and then months later a forensic audit happens. It is entirely retrospective. You are looking in the rearview mirror, trying to reconstruct the context of a financial decision made 3 quarters ago by an employee who may no longer be there.
true.
But with digital tax systems and real-time reporting mandates becoming the global standard for governments worldwide, that retrospective model is dead. The distributed agent model enables continuous compliance because these specialized agents are embedded directly in the operational workflow, reading the native data without copying it, validating financial data in real time. They ensure that accounting records, tax reporting, and statutory filings are consistently accurate at the exact moment of execution.
I will certainly acknowledge that continuous compliance is a powerful theoretical benefit. Moving away from the forensic archaeology of yearly audits to a real-time automated health check is essentially the holy grail of corporate accounting.
Right.
Instead of dropping everything to prepare evidence for auditors after the fact, organizations can generate automated, cryptographically secure audit evidence continuously. I get the appeal, but we absolutely have to link this back to our earlier point about vendor-maintained semantic mapping.
How so?
Because generating automated audit evidence continuously implies that the enterprise's systems are in a constant, unbroken state of surveillance by these algorithms. If the underlying semantic mapping, which, as we established, your internal IT department does not control anymore, has a fundamental flaw in how it interprets a specific, nuanced corporate transaction, then your continuous compliance engine will just continuously generate flawed audit evidence.
Well,
You won't just have a mistake. You will have a cryptographically verifiable, perfectly traceable record of systematic non-compliance operating at machine speed.
I see why you think that, and the fear of systematic error is valid.
But what is the alternative? The alternative is discovering that exact same systematic noncompliance 18 months later during an external audit, at which point the financial damage, the compounding errors, and the regulatory fines are exponential.
Right.
The real-time nature of the agentic network means anomalies are flagged and corrected in the moment. The system learns continuously through dynamic vendor updates rather than relying on static, internally built ETL pipelines that become obsolete the moment a new business unit is acquired.
Assuming the vendor updates are perfectly aligned with your unique business logic, which is a massive assumption for complex multinational enterprises.
Look, let's pull back and look at the broader strategic choice leaders are facing right now, because the data we started with is unambiguous. The traditional overlay approach, extracting data into centralized lakes, promises quick experimentation. It feels safe because it's how we built software in the 2010s, but it leads directly to the 95% failure rate.
Yeah.
It leads to years of data integration challenges, ballooning cloud storage costs, and fragile architectures that lose their semantic meaning. The only proven way to cross that chasm from pilot to production is to embed the intelligence directly into the familiar workflows. You dramatically increase adoption through effective change management because the user doesn't have to go to a new portal. The AI is just in the system they already use. Activating the intelligence already inside systems through zero-copy architecture and specialized agents is how you achieve continuous compliance and measurable financial outcomes.
And from my perspective, while a 95% failure rate absolutely demands a serious reevaluation of how we deploy AI, treating centralized data lakes as completely obsolete is premature. Breaking down enterprise silos requires some level of centralization to maintain a unified, cross-departmental view.
Furthermore, the alternative proposed today, distributing intelligence deeply into localized systems and relying on a sprawling, highly complex Internet of Agents to autonomously execute ledger adjustments, introduces massive new governance risks. Surrendering the maintenance of semantic mapping to external platform providers fundamentally weakens enterprise IT control in a way we may deeply regret.
I mean, what we are really talking about here is a profound shift in what we expect from software as a whole. I think we both agree that the era of AI merely thinking, generating insights, writing summaries, creating dashboards for humans to act on, is largely over. The era of AI acting has firmly arrived.
Yes, I think that is undeniable. The shift from chain of thought to chain of action is happening, regardless of whether you adopt an overlay model or an embedded model. The sheer pressure from boards and markets for measurable financial outcomes is forcing the technology to move from observation to execution.
Exactly. And that leaves enterprise leaders with a fundamental architectural decision that will determine whether their AI initiative becomes just another abandoned pilot or a transformative operational capability. It circles right back to that collapsing bridge we talked about at the start.
Right.
You cannot fix a structural flaw by pouring smarter concrete. You have to change the blueprint. The real question is whether your organization will continue trying to build AI on top of its systems, or if it has the courage to activate the intelligence already living inside them. There is so much more to explore in the 2025 MIT Project Nanda research, particularly regarding the specific cryptographic protocols these agents use to communicate. And I highly encourage listeners to examine their own organization's AI architecture through this lens. Thank you for joining us on The Debate.